Hello friends, today I want to discuss with you the origin of band in solid state physics. I will not discuss from quantum mechanical point of view, rather here we will consider the classical origin, because from quantum point of view we have to discuss about Kronig-Penney model. Now, unless we know the origin of band, we cannot understand the various electrical properties of solids. Actually, when two atoms are isolated from each other completely, then there is no interaction of electron wave function and they can have identical electronic structure. But as the spacing between them becomes smaller, electron wave functions begin to overlap and Pauli's exclusion principle comes into play. The exclusion principle states that no two electrons of an interacting system can reside in a same quantum state. So there must be splitting of the discrete energy levels of the isolated atoms into new levels belonging to the pair rather than to individual atoms. So the energy level belongs to atoms only and the energy band belongs to solids. Thus, in a solid, many atoms are brought together so that the splitted energy levels forms essentially contains bands of energies. Therefore, I can say now from this discussion that it is a semi-classical model. For example, if we consider the formation of energy band for diamond crystal from isolated carbon atom. As you can see, there are two 1s state, two 2s state and 6 2p states and all higher states for carbon atoms. For n atoms, there will be 2n 1s state, 2n 2s state and 6n 2p states. Now, as we decrease the separation between the isolated carbon atoms, the wave functions begin to overlap and actually form a 2s 2p composed state, which contains altogether 8n states, 6n plus 2n, 8n states. Now they forget about how they formed. Now, as we decrease further the separation between the carbon atoms, then they will form bands. The upper band is called conduction band, the lower band is called valence band. Now, at the exact diamond lattice spacing, from the figure you can see the difference between the lowest energy of conduction band and the highest energy of valence band is called Eg, energy gap. Now remember, there is no allowed energy levels. So sometimes it is also called forbidden energy gap. Now, according to the probability, the 2s 2p composed state contains 18 states. Then the conduction band and valence band will share each 4n states. Now, the question is, before the formation of bands, you can say what I have discussed just now, that one state was 2n, two states were 2n number, and 2p states are 6n numbers. And now the conduction bands shares equally 4n and with valence band 4n, but the ground state remained again 2n state. Now the question is, what about electrons in the bands? If we consider at T not is equals to 0 Kelvin, the ground state, there was in ground state there was 2n electrons. They will not share it with anyone, and the remaining 2n electrons can occupy any state or both the conduction band or valence band, whatever they want. But the question is, the very important thing is, what will happen at T is equals to 0 Kelvin? Ground state will contain, as before, 2n electrons. Valence band will contain 2n electrons because valence band consists of 4n states. So they will contain 2n electrons, and the conduction band is totally empty. So we can, from this discussion, we can have an idea of band. Now, from the band structure, we can differentiate metal, semiconductor, and insulator at T is equals to 0 Kelvin. As we all know from our 10+2 level that in case of insulator, this energy gap is very large. The conduction band is totally empty, the valence band is filled, and at room temperature we cannot have sufficient energy to lift the electrons, to excite the electrons from filled valence band to conduction band. Now from the figure you can see at T is equals to 0 Kelvin. For semiconductor, these band, filled valence band and empty conduction band, the energy difference between filled valence band and empty conduction band is Eg. I can give you a rough idea about this energy gap. At T is equals to 300 Kelvin, the energy gap is about 10 electron volt. Whereas for semiconductor, this energy gap is 1.1 electron volt for silicon, 0.67 electron volt for germanium, 1.35 electron volt for indium phosphide. So you can guess that by giving a small amount of energy, we can excite many electrons to the empty conduction band. So this is called semiconductor. Semi means it becomes conductor after increasing, as if we increase some temperature or if we supply energy by any means. Now, in case of metal at T is equals to 0 Kelvin, the conduction band and valence band overlaps, or it may happen that there is partially filled conduction band. So from this band theory, we can exactly see the origin of the difference between the metal, semiconductor and conductor. Thank you. Hope you can have a detailed idea, a clear idea about what is band and how we can separate metal, semiconductor and insulator with the band, this semi-classical argument, from this semi-classical argument. Thank you.